Welcome to GovCast, connecting with federal IT's top decision makers. I'm Alexander Bolova, production lead at GovCIO Media and Research. With me today is staff writer-researcher Nikki Henderson. Hi, Nikki.
Hi there, Alex.
So you had a chance to chat with Frank Indiviglio, CTO at NOAA. How'd it go?
It went well. Frank shared some really great information with me about the benefits NOAA is seeing with artificial intelligence when it comes to weather modeling and forecasting. So, Frank also touched on how important software environments are to driving innovation at NOAA and the role the agency's information resources management strategic plan has played in developing a more IT and data literate workforce. So it was a real informative discussion, Alex.
Awesome. For as much as weather is the go-to conversational topic, I don't really spend too much time thinking about how we get weather predictions and the technology that goes into that. So this is a really interesting insight into a very specific area of that. So NOAA is seeing a lot of opportunities with edge computing, which I know we've talked about in other contexts, but not necessarily in a weather one. How did Frank describe edge computing playing a role in forecasting and data collection?
Well, Frank said edge computing will help produce a better forecast product overall. He said edge computing will be so valuable to NOAA because you can put these tiny tech tools or devices in harm's way without putting someone's life in danger to gather that crucial weather data. So, for example, Frank told me they put sensors on uncrewed vehicles or devices and they send those things into harm's way, and like with a tornado or a hurricane, he said it provides critical information, especially let's say for a hurricane to forecasters. And it just provides that data that they need quicker and better. So in a weather situation, we know that time is of the essence. When someone's in harm's way, you want to get them that information as quickly as possible so they can move to a safe place. So he said it's really helping with giving forecasters that quicker data and better data, more accurate data as far as a storm is concerned.
Right. And I guess what makes it edge computing is the fact that when you're putting sensors into hurricanes in the ocean, you're not exactly near a cell signal or really any kind of traditional infrastructure. And so edge computing is the only way that you can collect data in these environments that just aren't really suited for technology. Am I right?
Exactly. Exactly right.
So I know that NOAA has the Open Data Dissemination Program. What did Frank say about this, and how is it making things like weather forecasting more accessible to the public?
Frank said NOAA's Open Data Dissemination Program, or NOD, as he calls it, is cloud based. So it provides the public with tools that they can immediately use to get the data they're looking for. So that's a real plus. And then Frank said NOD also offers multiple data sets that anyone can download and look through anytime they want and at no cost. So the real goal of NOD is to make that weather and modeling data more available to their stakeholders as well as the public.
Gotcha. I feel like we just rolled past the opportunity to make a joke about NOAA and cloud and weather and all that, but unfortunately, that time has gone. No puns for now. Anyways, I'm going to take an absolutely wild guess and say that artificial intelligence came up in your conversation. Am I right?
You guessed it.
Yep. So, how did Frank say AI was affecting forecast accuracy and climate modeling at NOAA? And what are some challenges with this emerging technology?
Frank talked about how, well, the benefits. AI is really benefiting NOAA in many ways. It's helping decrease the amount of computing that they have to use. And Frank said it also provides NOAA with the opportunity to focus most on the compute of the storm rather than outside of the storm. He said, which is extremely helpful. And AI is also even reducing data movement, which is a really big plus for the agency as well. However, Frank also discussed one of the main challenges with AI, and he said, of course, that is adoption, which he said, and we all really know this, with most emerging technologies, people are hesitant to adopt it. So he said you have to get your workforce to embrace it, but before they can do that and before that happens, they need to understand it and trust it. So that was the thing, that the big challenge is adopting AI.
I mean, I have to be honest, I'm also concerned that if we start putting AI into the clouds, then robot overlords are going to take over the weather and it'll be raining like literal cats and dogs or whatnot. So I'm approaching this interview looking to have my mind changed about the role that AI can play and some reassurance that it's not going to cause a Sunny with a chance of meatballs scenario.
Yeah, Alex, I have to agree with that.
Well, with all of that in mind, let's take a listen to your conversation.
Good afternoon, Frank. I hope you're doing well today.
I am. Good afternoon to you, and thanks for having me.
No problem. I really appreciate you taking out time to speak with me today about NOAA's Information Resources Management Strategic Plan, the role supercomputing plays in the agency's forecasting missions, and other tech initiatives on the horizon for this year and beyond. Well,
Great.
Frank, let's go ahead and get started. I'm very interested to hear about your career path. Can you start off by talking about your previous positions at NOAA and your time at Cornell and Columbia universities and how they led you to your current role?
Oh, thank you. So that's a great question. It's been a fun career path from my perspective. I've enjoyed getting involved in the science side. I started off on the technology side, but I've been at NOAA for somewhere between 12 and I guess maybe it's almost 15 years now that I think about it. And I've been the CTO for about a year, and before that, I was a deputy director for high performance computing. So my day job then was making sure the research and development HPC within NOAA kept growing and kept running, and making sure that our science was able to get done on those resources. And that was a fun job as well. It's kind of an eye-opening experience to see all the science research that goes into your weather forecast and the climate reports. So always an interesting job. Kept me on my toes for 5 years. Before that, I still in the HPC program, and I was really I was supporting a lab. So there's a lab in Princeton, New Jersey called the Geophysical Fluid Dynamics Laboratory, and that's in the Office of Atmospheric Research. So I supported the scientists at GFDL for most of my time at NOAA. I was a site lead. Before that, I was an analyst. I started off as a programmer. So I kind of run the gamut of modeling within NOAA on the research side, specifically on the climate side. And before that, I came from, we work with really New York Presbyterian Hospital, but it's split in half between Cornell and Columbia universities. So I worked at both, split my time there. And that was, I guess, the job that really kind of sparked my interest in supporting science. So before that, I worked in IT and high performance computing, but it was, from industry. And when I moved to the lab in Cornell, I got to kind of really work with science and the workflows that support it and all the things that scientists worry about on a day-to-day basis, not just, here's a solution, we can make it work. It was more of the how we're going to get our science done. And it was really kind of interesting and not very different from NOAA, but it's a smaller scale, right? We're doing genomic sequencing and molecular dynamics, right? So the universe is very small in those problem sets, but there's a lot of information there. So it was it kind of, one thing led to another, right? At both Columbia and Cornell, we were, doing a lot of plant biology and some human biology, and they really kind of spurred my interest in supporting science. And I found my way into weather, and I've stayed here ever since. And I think both of those endeavors were great for me to learn. I get to learn a little bit of science. I get to stretch my technical muscles. So I think overall, it's been a really great trip.
Oh, wow, Frank, that's very interesting. Thank you so much for sharing that. Well, can you tell me about the progress that has been made with NOAA's Information Resources Management Strategic Plan, and how has it prepared NOAA for having an IT and data literate workforce?
So just for a little background, so we have a new IRM plan that was released in 2021, so it's newer. It's not, and now it's 23, but it's a little newer. So I think it's really, it kind of focuses on the right things, right? So the first focus is obviously the people within NOAA, right? The scientists that we support, the IT workforce that I'm part of and I need to support as well. So I think a lot of the growth that really prepares people for IT data literacy is kind of moving forward pretty rapidly there. So one of the things that we really invested in is an IT fellowship program, which gives a lot of opportunity to folks to really understand, the mission of NOAA, get involved, get that first job or college internship, but really get exposed to the agency. And I think that's the important part of federal workforce, right? Getting people involved and getting people really in love with the mission, right? I mean, I think a lot of the people at NOAA, and I'm sure this is true for other agencies, but especially at NOAA, people really love the mission, right? That's why I'm here. That's why the scientists are here. So getting those folks in and getting them, exposed to and really involved and kind of not bought in, but involved in that mission and really kind of fall in love with it, just like the rest of us have. I think it's really helpful to not just to bring new folks in, but different perspectives. Obviously, there's a lot of, we need to modernize and new faces bring part of that in. So I think that's a really good aspect of it. On the, from the technology side, really making sure, we've all gone kind of through our trials through COVID and working from home. And I think that's, part of the new paradigm, right? Where we need a more mobile workforce, right? So one of the tenets of the strategy is how do we enable or empower our users to be more mobile, right? So we're working down a path of replacing desktops with cloud services, or replacing a lot of the tools that we're used to with their cloud, corollaries, so that you can work from home easier. You can work from wherever, travel, wherever you may be. A lot of our researchers are out in the field, and they need tools just like they would be in an office, and sometimes those are harder to get out there. So how do we make that, empower that across the whole workforce? So that's a lot of the work that's going in there, and I think that not only will improve services, save money, and those are all good things, but really gives a richer tool set for the folks that need it, right? And then from a knowledge perspective and a knowledge gain, knowledge building aspect, we do a lot of work, with our academic institutions, right? We have a lot of partner academic institutions. We partner a lot with industry folks, and really one of the better outcomes of those partnerships, obviously the partnerships have a lot of really good mission and IT outcomes, but one of the things that we focus on is that skill building, right? So you talk about AI and data, and those are kind of hot topics, but it's something that people need to get a better understanding of and really, kind of get their hands dirty with it, so to speak. And really, you need hands-on experience to do that. So we've been able to do a lot of things like hackathons and workshops across NOAA. The HPC program that I used to be involved with did a lot of them. We do one every year. And it gets people exposure to new technology, new methods, gets them talking to their peers, gets them talking to industry experts. So it's a really good way of getting people involved in a fun way, and giving them the space to kind of explore a little bit. And I think those are the kinds of ways that will really kind of drive, the IT strategy home, right? Having that workforce and having it mobile and right? And you wrap security around that, right? And now we have to make all this stuff work. But I think the getting that all together and having the people involved is the important part, and that's where we're focusing.
Right. Well, that's great. I like what you said about people, loving the mission. That is very important. And equally as important is having a mobile workforce, especially since the pandemic. So that's very important. Well, Frank, what role does supercomputing play in NOAA's forecasting missions? And how will new supercomputing capacity benefit the agency's modeling system?
Mm-hmm. So it's central to the forecasting mission. And I tend to reference it as kind of the crossroads of NOAA, right? So, all of our missions start with observations and end with the products, and usually at some point those observations run through an HPC system to either become part of a forecast or part of a product in one way or another, right? So it is central to the mission. It is a crossroads for that observation of products. But just to kind of give you an idea of what gets produced in there, right? So the products that we do, forecast products, we'll say, they span from minutes to centuries, right? So minutes are tornado watches and warnings. Centuries are things like climate reports, like the IPCC that gets published every 5 years. And NOAA is a big part of it, and other agencies are as well as other governments. But there's a wide berth of things that happen in there, and they tend to build on each other, right? Weather and climate are, the same systems at different timescales and resolution, right? So it's an important capacity for NOAA. It's something that we pay a lot of attention to because our capacity needs grow at a rate that is they grow at a rate that is kind of it's interesting to watch because as scientists get deeper and deeper into a problem and go at a higher resolution, so as they get closer and closer to the real world in terms of the modeling, the compute that they need, you think, okay, well, if we're going to double resolution, we need more. We just need to double compute, and sometimes that's true. Most times it's not. Most times it's 4 times, and if you look at the data aspect, it's 8 or 9 or 10 times, and really those things grow at a kind of an interesting rate. So we got to make sure that we keep ahead of the capacity and keep those scientists where they need to in their experimentation. So it's central to it. It's an ever growing capacity, and it's one of the things that we really like working on. So yeah.
Okay, great. Thank you. Well, how does edge computing enable NOAA to push workloads out to the public, and how does it help with data collection and analysis?
So I think that's an interesting area, right? So edge computing offers us a lot of opportunity, right? So I mentioned before about researchers that are in remote places, right? So edge computing, that's kind of an easy way to look at it. Now you can pack a lot of technology into a pretty small package, right? So you can buy what would have been probably considered a supercomputer, 5 or 6 or a little bit maybe more years ago, and you can buy them into a little box that you could probably fit on your desk, right? So you can move those kinds of assets to out into the field, or you can really instrument either uncrewed vehicles or crewed vehicles with more data gathering capabilities, more processing capabilities, which means that, if you have scientists in the Arctic or the Antarctic or wherever they are, really far away from networks, away from other technology, you can give them that technology, or from them in the middle of an ocean on a boat. Obviously, they can have that processing. But more importantly, it allows us to do things like start processing in the field, right? Where we don't have to worry about or wait for data to start coming back. We can start doing that processing out in the field and really pull the data that we need right away. So why is that good? That's good because the quicker that we can get the data, the better we can prepare it. The later in the forecast cycle we can put it in, that means a better forecast product, right? So with up-to-date information, everything improves. So we can start doing that, hopefully in the field with edge computing. And you can put things like small computers or technology, into harm's way where we couldn't do that before, right? So sensors and uncrewed vehicles can take surface surface readings from the ocean in front of a hurricane where, a person wouldn't do that, and where would you want them to? And these can be dropped, from vehicles or whatever, but they can go into harm's way, and the loss, obviously it's a small amount of money, but you get all this rich data. So they can really extend that forecasters or scientists' reach by getting more data faster and getting a better answer quicker.
Okay, yeah, that's totally understandable. That's wonderful. I mean, that's definitely, like you said, don't want anyone to be in harm's way, and a small, I guess, price to pay for the device sensors to get that rich information, that rich data. Well, Frank, can you please talk about NOAA's Open Data Dissemination Program and the benefits of having that public-private partnership when it comes to making data more accessible?
So the NOAA Open Data Dissemination Program, which is a very it's a mouthful. We'll call it NOD from now on. That's the acronym we use inside. It's an interesting program. I mean, going back to what we talked about with all the data that we collect, produce, to give you an idea of scale, we'll go back to an HPC example for right now. One HPC system can generate about 7 terabytes an hour. It does that every hour of every day, right? And we have, on the R&D side, there's 5 of those. So depending on scale, that number can go up and down, but it's already a pretty big number. And the systems get bigger and more complex, that number goes up, it doesn't go down. So if we're generating that much data just from HPC, or we're collecting all this other data that's tens of terabytes a day from satellites and boats and radar and everything else, that data has value not just for the science community, right? Not for the folks at NOAA. It has obviously value for the public and academic research institutions. It's got economic value, right? There's a lot of businesses that either need the data or are built around this data. So getting it out, and most of the data, if not all of the data, is available to the public, but you have to know how to get to it, or you have to have your own processing or be able to download it all before you can start working with it. And I think the goal of things like NOD is to get it in the public sphere near tools that you can use right away, right? So the nice thing about NOD is that it's cloud-based, right? It's across 3 cloud providers. There's there are a number of data sets out there that you can freely go look through. You can download them for your own use, or you can use them right in the cloud environment. There's no cost to the taxpayer, right? So you as a citizen go and download whatever you want, or use tools that you're, to go do that. But I think the real benefit is having that data in a very accessible way that people are used to. It's good for scientists, it's good for industry, it's good for the public. It's at no cost, but it does drive an ecosystem around those tools, right? So around the data to generate things like tools that people will need that are common, and really bring people together around that data where it may have been, situated in an academic institution. It opens up the area of collaboration, I think, a lot wider than through our historical ways of putting data out into the public. So it's really about getting the data more accessible and more accessible to the public and our stakeholders.
Okay, great. Thank you, Frank. Well, how important are software environments when it comes to driving innovation at NOAA?
They're really important. I would say they're more important than hardware these days. So I think software, and not to sound like a tech, like a normal tech person, software is really driving everything here. Hardware, we're getting through this period of, on the HPC side where hardware has been kind of stable, right? We've bought, kind of similar processors. We're kind of used to this software environment, and that's changing. It's changing rapidly, right? So we have GPUs, which are very different from regular CPUs, right? You have to really think about how the software is put together, and that hardware arena is getting much wider, right? So you see things like ARM processors, which are lower power, which is also a concern for us, but making sure that we can have modeling and software environments and really applications that run across all of these things it takes work, right? It takes refactoring. You have to make sure that we're planning for new architectures. So we do that in a couple of ways. We do have, not standard, but programs within NOAA where we have people looking at architectures, really kind of pushing the envelope on where we can deploy things or how we can improve them. So, we can get performance out of software or out of hardware, excuse me, but it's not like it used to be. So we have to look to software. So refactoring those codes, making sure they're modernized, looking at different languages, looking at different hardware, all give us more capacity, right? So we can buy capacity, but with software, we can enhance the capacity that we have and prepare ourselves for even more capacity later, really stretch out the HPC or the whatever processing that we have, really to get deeper into the problems that we're looking at, or just get things done faster. So I think that one of the things that software will provide us is the scale and really the capability, right? So we can look at problems in a deeper way. We can scale problems to larger systems, and that's important for lots of things. And it'll change, as AI and HPC and AI and everything else kind of meld together in the future as we're all going down this road together. I think that'll become even more important because the software environments across those disciplines or across those sub parts of computing are a little bit different, but they'll have to start kind of folding together to make sure that we can all work together.
Right, right. Well, you just mentioned AI. So I wanted to pivot our conversation a little bit to artificial intelligence, AI. AI is improving the accuracy of forecasts and freeing up people to do more science. Mm-hmm. Can you talk about some of the challenges that NOAA is facing when moving data across its multiple systems, and how is AI helping to simplify the process?
Mm-hmm. So that's a good question because data movement is expensive. When I worked at the labs, I don't think I met a data tool that didn't fail and didn't tell me. So the less data we move, the better off we are. So I think AI is helpful in a lot of ways, and so let's start there, and we can talk about challenges. But I think the benefits are it can reduce the amount of computing that we use. Right, there's a lot of kind of from a weather or climate model. You have to run a lot of copies of the model to deal with kind of uncertainty in initial conditions, right? So you want to make sure that you're covering all of the possible, start conditions that you have to account for, and you can reduce that number by redoing the parameterization with AI. And I'm not going to get in the weeds, but it allows us to get more science out of the compute that we have, but it can focus the compute that we have on things that we're really concerned with, say a hurricane model, right? AI can do things like help us focus most of the compute on the storm rather than outside of the storm. So there are lots of ways that it can help reduce either data movement, but certainly get better answers. I think the challenges are in any organization, and we're no different. I think the challenges have been adopting it, right? And not so much. I think there's a lot of people who want to adopt AI methods within NOAA, within the government, but it is a new technology, right? You have to get your arms around it. You have to really understand it, and it goes back to the workforce stuff we were talking about before. So you have to have data scientists and machine learning experts and other things that you have to build around your science teams, and that's that I think is more of a challenge. And I'm sure this is not specific to NOAA, but I think, because we work in the science domain, having, software engineers or AI experts and scientists all working together requires almost the development of a common language, right? And that requires training, and right? So having those kinds of programs there to bring those folks together and kind of start working towards that shared language and really moving everybody forward together, I think that's the real win there. But I think it's also a challenge, right? You have to develop your workforce so you can get to a place where you can really rapidly adopt these things, make them usable, so that you can go through your normal scientific process to make sure that they're usable and people trust them, right? There's a lot of trust in the weather, right? Everybody's got to understand what the answer is and why we got there, right? And that's part of it, right? So the analysis has to happen, and getting those people together is important.
Yes, I agree. I totally agree. Well, is there anything on the horizon or anything that you're excited about as far as future IT initiatives?
Well, I think, all right, so future IT, well, I think, let's talk about technology for a little bit. I think, we're just talking about AI, and, AI is exciting on its own. But I think there's a lot of, recently, right, we have a lot of the generative AI tools coming out from various vendors, and I think people are really interested in looking at that. And from my perspective, right, I think that there's a whole bunch of sciencey stuff that I'm sure people will want to implement there. But from a technology organization, I think these are the kinds of tools. We have to be careful. We have to make sure they're secure. We have to make sure our data is secure. But we really have to look into these things, because it allows us to manage. It might allow us to manage systems better, document things better, take people away from doing kind of the routine tasks, and really open up time in their day to do more mission support, dedicate resources towards that mission. So whatever we can do to help automate folks into, a better place, or supporting the mission more, I think is good for us, and for them, and for everybody involved, right? So, and it's one of those things that I think, like any, AI has been this kind of rapidly developing thing, and this is the last, the last little increase, not capability that we've seen. I'm sure there'll be more, but I think this is one of those ones that it can change the way we do things, and I think those are the ones that I get more excited about, because I can see the value, which is just having to get there, right? So those are fun. Hybrid environments have always been something that I really care about, right? We talked about HPC and capacity, right? So any which way I can get capacity into those things, into those systems, whether it be through cloud or through different architectures, I think those are going to be the real fun problems to look at. People talk about hybrid, multi-cloud. I think those are important, but finding the right place to run your job when you need it, whether it be inside or outside or somewhere else, I think those are the really important things. And again, the AI stuff that we were talking about will push systems to a new place, right? We generally deploy a lot of uniform systems we're focused on high performance computing, or we're focused on the scientific problem. And I think in the future, those systems will change, and they'll be hybrid, and some of it will be AI, and some of it will be HPC, and some of it will be data analysis. And there's all kinds of different ways that you can kind of twist that architecture to get the jobs done. And I think that's going to be kind of the interesting part of, okay, the hardware is different, and we have this kind of hybrid infrastructure to support all this. And that's a technically hard problem, and we have to figure out how to make that work. And like, that's the kind of puzzle that excites me. So that's the other area. And then on the last thing, which is not, it's technology based, but I think one of the things that we have to kind of have an eye towards is sustainability, right? Systems are getting bigger. That means more power. Obviously, we want to make sure that we're doing it in a way that's good for the environment, good for the taxpayer. So I think there's a lot of opportunities there. You see a lot more or larger solar, sources coming out. There's a lot of really pushes in the industry to get to that sustainable practice. You can see that in the cloud vendors. You see, other parts of the industry. We're certainly looking towards it, and I think that'll be another aspect of kind of a really fun set of initiatives, because data centers can't get bigger without us fixing this problem, right? We can grow to a certain point, and then we need a power plant for a data center, and that's untenable. So how do we get there in a way that's clean and sustainable going into the future?
Great. Yes, there are truly a lot of exciting things going on the IT front. So thank you so much for that. Well, before we conclude, Frank, I wanted to know, do you have any final comments, remarks that you would like to leave with our listeners?
Well, I think that, so I would say that we live in exciting times for technology. And I think that, I'm going to be interested to see what happens in the next, 6 months and a year, where things like generative AI and other things we talked about are really going to have an impact, right? At home, they already have an impact at home. Everybody's got Alexas and whatever else at home, but you'll see that stuff change, and it'll be on your desktop, and it'll be in your web browser. So I think those are the kind of things that'll be exciting over the next year, and things that I'm going to be watching out for. So yeah, it's going to be an exciting little technology influx here.
Right. Well, great. Well, Frank, I really did enjoy our conversation today. It was really informative, and I really appreciate you taking out time to speak with me about what's going on, the latest happening at NOAA. So I really do appreciate it.
All right. Thank you. I appreciate being here. This is a great conversation. I really appreciate the time and having me on. This is great. Thank you.
Thank you, Nikki. I've got to say, I am less afraid of AI potentially taking over the weather. It was a really fascinating conversation to hear about how all of this new technology is improving our weather forecasting capabilities and also its accessibility. So seems like a really exciting time at NOAA.
It definitely is an exciting time at NOAA. And what's so great is that NOAA really is going the extra mile to equip scientists with the innovative and tech tools they need, as well as providing forecasters and the public, you and me, with the most accurate weather data and having more accessibility to that data in a timely manner, ultimately to keep all of us safe. So, and edge computing is definitely helping with that, as well as AI. And then, I'm just really excited to hear about more benefits that NOAA will see with AI down the road.
As am I. Nikki, thank you so much for another great episode of GovCast. We'll be back next week with a brand new episode. But until then, if you like what you heard, please leave a 5-star rating and a review on the podcast platform of your choice. I'm Alexander Bolova.
And I'm Nikki Henderson.
Thank you for listening. GovCast, along with HealthCast and Cybercast, is a production of GovCIO Media and Research. For more podcasts and to check out the other shows, head to govciomedia.com. Watch out for new episodes released every Tuesday and Wednesday across our shows. You can follow all of them on your favorite podcast platform. And if you like what you heard, make sure to let us know by leaving a review. And if you have any topics you think we should look into, contact us at newsletter@govcio.com.